Hello everyone, welcome to chemistry classes. Okay, so today we will discuss about the insulators, conductors and semiconductors. In the previous session we have discussed about the what is resistance, what is conductance, what is resistivity, what is conductivity. Okay, so now we'll discuss about what are insulators, what are conductors, what are semiconductors. So here all the materials they are divided into three parts based on their conductivity. So just this classification of the materials is just based on their conductivity. Depending on their conductivity, they are divided into three classes: insulators, conductors and semiconductors. The materials which have got the lowest conductivity, so they are grouped into insulators. They are called as insulators. Here the conductivity range of these insulators is 10 to the power negative terms, 10 to the power minus 6, minus 10, minus 20, like that. So example for insulators. Insulator means the compound which do not allow electric charges pass through it, means it do not conduct electrical current. They are called as insulators or non-conductors. Example: benzene, ceramic materials, glass, etc. Benzene, ceramics, glasses, all are the non-conductors. And some plastics are also non-conductors. But nowadays we are preparing the plastic materials which are conducting in nature. Okay. Next, the second type of compounds is conductors. So conductor means what? So these are the materials which have got good conductivity range. Their conductivity range is in between 10 to the power 4 to 10 to the power 7. 10 to the power 4 to 10 to the power Simon per meter. Okay. So these compounds are called as conductors. The compound which allow electric charges pass through it, they are called as conductors. So the best conductors are said to be metals. Metals are best conductors. So their conductivity range is 10 to the power 7 Siemens per meter. Okay. Now metals are conductors. Graphite is a good conductor. We have learnt in topic 1 only, or in first also we have learnt that graphite is a good conductor, and the carbon black is also good conductor. Carbon black. And in carbon black the electrons are sp2 hybridized. So because of that reason, what happens? There exists a free electron which is responsible for conduction. So by carbon black we can prepare fullerenes. You must be remember that fullerenes. And some organic polymers. Nowadays we have some polymers are synthesized. Organic polymers, those are also conducting in nature. Some organic polymers are also conducting in nature. If a polymer is said to be a conducting polymer, there is a characteristic property, that is that polymer should contain pi electrons. So those pi electrons should undergo conjugation. If a polymer contains under 5 electron conjugation, then it is said to be a conducting polymer. Okay. And the last class of compound is semiconductors. The word itself, the name itself indicates semi means what? In between or half. Conductors. The conductivity range of these components is in between insulators and conductors. So they are called as semiconductors. Example: silicon, germanium, etc. So these are the semiconductors. About them we have learned already. We have learned about them in our solid state, isn't it? Okay. So now let us study more about conductors. So these conductors. Okay, before going to this further classification, and there are some materials which are said to be superconductors. The process of superconductivity. The superconductors have got infinite conductance. The conductance of those components is infinite, means the superconductor have got infinite conductance. If a compound has got infinite conductance, its resistivity is equals to 0. So nowadays we are synthesizing the superconducting materials. In older days, the superconducting materials are functioning only at low temperatures, around 0 to 15 Kelvin temperatures. 0 to 15 Kelvin. In older days, the superconducting materials have synthesized, but those materials they are functioned only at 0 to 15 Kelvin temperatures, at very much lower temperature. But nowadays we are successfully prepared superconducting materials which are very best, and they can function, they can operate at high temperatures of about 150 Kelvin. You can use them at 150 Kelvin. They can show superconductivity even at this much high temperatures. Okay. Okay. Now we'll go for further classification of them. Now we'll go for further classification of these conductors. The conductors are further divided into two types. Okay. The first one is called as metallic conductors. Metallic conductors, they are also called as electronic conductors. Metallic conductors are also called as electronic conductors. Here, second type is electrolytic or ionic conductors. Electrolytic conductors or ionic conductors, they are also simply called as electrolytes. The conduction. Okay. Now, in metallic conductors, the conduction is due to free electrons. In metals, who is responsible for conductivity? Yes, the free electrons are responsible for the conductivity in metals. So, because of this reason, they are called as electronic conductors. As electrons are responsible for their conductivity, they are also called as electronic conductors. Electronic conductors. And next comes electrolytic conductors, or they are also called as ionic conductors. In these ionic conductors, the conduction is due to ions. The conductivity is due to presence of ions in the electrolyte. So due to the presence of ions, they conduct electric current. So they are called as ionic conductors. So due to the presence of electrons, these conduct electric current. These are called as electronic conductor. So now let us study more about them. The factors on which metallic conductor depends. The metallic conductor depends upon these following factors. First we will discuss about them. A metallic conductor depends upon nature of the metal. The metallic conductor depends upon nature of the metal and its structure. The conductivity of metallic conductor depends upon nature of the metal and its structure. As nature and structure changes, its conductivity also changes. So about this we have learnt in our solid state, isn't it? So in solid state we have studied about the electrical property of solids and the correlation of these electrical property with their structure, isn't it? So now the conductivity of metallic conductor depends upon nature and structure of metal, and it also depends upon number of valence electrons per atom. If a metal gives if a metal contains more number of valence electrons, if the more number of valence electrons are there, it has got a high electronic conductivity, or the conductivity of metallic conductor increase in the number of valence electrons per atom. So if more number of electrons are present in the outermost orbit, so its electronic conductivity also increases, because as more number of electrons are given to the structure or given to the lattice or given to the crystal, so those all electrons are responsible for the electrical conductivity. Next, the most important thing, the conductivity of metallic conductor also depends upon temperature. The conductivity of metallic conductor also depends upon temperature. So here the conductivity of metallic conductor decreases with increase in temperature. Please remember, the conductance of metallic conductor decreases. The conductivity decreases with increase in temperature. As temperature increases, conductivity decreases. This is because why this thing happens. Here, if I consider this is my conductor, I'll consider this is my conductor. So in its body there are free electrons. In the body of the conductor there are free electrons. Those electrons are moving from one end to another end. The electrons are moving from one end to another end. If there is no obstacle in its way or in its path, then what happens? They move freely and they will reach their goal easily. They will reach another end very much easily. So if I pass electric current at low temperature, there will be no obstruction or no obstacle. So electrons from this end move freely towards this end. Means mean free path of those all electrons is maximum at low temperature. If temperature increased, what will happen? if temperature increases, as the temperature increases, the electrons will get high energy. The kinetic energy of electron increases. As kinetic energy of electron increases, the electron starts move fastly. As electrons start move fastly, what happens? There exists a collision. Means if an electron try to pass very fastly, it will collide with another electron. So now what happens? The direction of first electron changes. The direction of first and second electron changes. So as a result, what happens? Because of increase of these collisions, this electron which starts its journey from this end, it will take longer time to reach this end because of obstacles. So because of this reason, what happens? Because of this thing, as temperature increases, the conductivity of metallic conductor decreases. Okay, I hope all of you understood. So once again I'll repeat. ನಾವು ಇದು ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ ಅನ್ಕೋಣ. ನಾವು ಇದನ್ನ ಏನಂತ ತಿಳ್ಕೊಂಡು, ಈಗ ದಿಸ್ ಇಸ್ ಅವರ್ ಮೆಟಲ್, ಇದೊಂದು ಮೆಟಲ್. ಈ ಮೆಟಲ್ ನಲ್ಲಿ ಏನಿರ್ತಾವ ಅಂತಂದ್ರೆ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ. ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ ಏನ್ ಕೆಲಸ ಮಾಡ್ತಿರ್ತವೆ? ಈ ಎಂಡ್ ದಿಂದ ಈ ಎಂಡಿಗೆ ಏನ್ ಮಾಡ್ತಿರ್ತಾವು? ಮೂವ್ ಆಗ್ತಿರ್ತಾವ. ಮೀನ್ಸ್ ಅದಕ್ಕೆ ಎಷ್ಟು ಸ್ಪೇಸ್ ಇರುತ್ತಲ್ಲ ಅಷ್ಟೆಲ್ಲ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಅವು ಏನಾಗ್ತಾವ? ಫ್ರೀ ಆಗಿ ಮೂವ್ ಆಗ್ತಿರ್ತಾವ. ಬಟ್ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ, ಈ ಲೋ ಟೆಂಪರೇಚರ್ ದಲ್ಲಿ ಇಲ್ಲಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ಮೂವ್ ಆಗ್ತಿರತ್ತ, ಬಟ್ ಅದ್ರ ದಾರಿಯೊಳಗೆ ಅದಕ್ಕೆ ಯಾರು ಅಡ್ಡ ಬರೋದಿಲ್ಲ. ಅದಕ್ಕೆ ಏನಾಗ್ತಂದ್ರೆ ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಫ್ರೀ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇರ್ತವೆ, ಹೌದಾ? ಬಟ್ ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಆಸ್ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸಸ್, ನಾನು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ಕೊಳ್ಳಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ ಎನರ್ಜಿ ಏನಾಗುತ್ತೆ? ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಯಾವ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗುತ್ತಾ? ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. ಸೊ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಅಂದ್ರೆ ಏನಾಗಬೇಕು? ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಏನ್ ಮಾಡ್ತಾವ? ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ದಿಂದ, ಜಾಸ್ತಿ ವೆಲಾಸಿಟಿಯಿಂದ ಏನ್ ಮಾಡ್ತಾವು? ಮೂವ್ ಆಗ್ತಾವ, ಹೌದಾ? ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆದವು ಅಂತಂದ್ರೆ ಅವು ಏನ್ ಮಾಡ್ತಾವ ಅಂತಂದ್ರ ಹೊರಡಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾವ. ಅದ್ರ ವೆಲಾಸಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ವೆಲಾಸಿಟಿ ಜಾಸ್ತಿ ಆದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರ, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಈ ಎಂಡಿಗೆ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಫಾಸ್ಟ್ ಆಗಿ ಮೂವ್ ಆಗುವಾಗ ಫಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ಗೆ ಕೊಲೈಡ್ ಆಗುತ್ತೆ, ಡಿಕ್ಕಿ ಹೊಡೆಯುತ್ತೆ, ಹೌದಾ? ಸೊ ಆ ಥರ ಡಿಕ್ಕಿ ಹೊಡೆದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ದ ಮೂಮೆಂಟ್ ಆಫ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮೂಮೆಂಟ್ ಏನಾಗುತ್ತೆ? ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕಾಗಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದಂಥ ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿಗೆ ಬಂದು ರೀಚ್ ಆಗಬೇಕಾದ್ರೆ ಬಹಳಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ, ಹೌದಾ? ಸೊ ಟೆಂಪರೇಚರ್ ಕಡಿಮೆ ಇದ್ದಾಗ ಜಾಸ್ತಿ 10 ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ಬಿಟ್ಟಿವೆ ಅಂತಂದ್ರೆ 10 ಎಲೆಕ್ಟ್ರಾನ್ ಇಲ್ಲಿ ರೀಚ್ ಆಗ್ತಿದ್ವು ವಿದಿನ್ 1 ಸೆಕೆಂಡ್, ವಿದಿನ್ ಲೆಸ್ ದೆನ್ 1 ಸೆಕೆಂಡ್. ಆಮೇಲೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದಾಗ ನಾನು ಇಲ್ಲಿಂದ 10 ಎಲೆಕ್ಟ್ರಾನ್ ಬಿಟ್ಟರೆ ಆಫ್ಟರ್ 1 ಸೆಕೆಂಡ್ 1, 2 or 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮಾತ್ರ ರೀಚ್ ಆಗಿರ್ತವೆ, ಹೌದಾ? ಸೊ ಆಸ್ ಎ ರಿಸಲ್ಟ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? ದ ಕಂಡಕ್ಟಿವಿಟಿ ಡಿಕ್ರೀಸಸ್. ಓಕೆ, ಸೊ ಈ ತರ ಆಗುತ್ತೆ. ನೆನಪಿರಲಿ, ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟರ್ ಒಳಗೆ ನಾವು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ರೆ ಮೆಟಾಲಿಕ್ ಕಂಡಕ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತೆ? ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ the metallic conductance decreases with increasing temperature. Okay, so this is about metallic conductors. Now come to electrolytic or ionic conductors. Or here, and one more thing, metallic conductors are solids, isn't it? The metals are solids. These ionic or electrolytic conductors are liquids. The conduction of liquid solutions. Here the conduction of solid materials. The metals are solid. Here the electrolytes are liquid. Here in electrolytic or ionic conductors, the conduction is due to ions. The conductance of the material is because of presence of ions. So due to the presence of ions, they can carry electrical charges or electrical current from one end to another end. So they passes electrical current. The conductivity of electrolytic conductor depends upon following factors. So the electrolytic conductors or conductance of electrolytic solution depends upon the following factors. So here, what are those? Let's study them. The conductance of electrolytic conductor depends upon nature of electrolyte added. First, it depends upon the nature of electrolyte added in the solution or in the solvent. If my electrolyte, if the added electrolyte is strong electrolyte, what will happen? The strong electrolytes always undergo complete dissociation. As dissociation is complete, more number of ions are present in the solution. As number of ions are more, the conduction is also more. If the electrolyte is weak electrolyte, for example acetic acid, what will happen? If I dissolve 1 mole of acetic acid, means okay, not 1 mole, I'll take 100 molecules of acetic acid, only 10 molecules of acetic acid are dissociated in the solution. Means the solution contains only 10 H plus ion and 10 CH3CO minus ion. the conductance of those ions, those solutions are very much less. So the conductance of electrolytic conduction depends upon nature of electrolyte. If electrolyte is strong electrolyte, it will conduct more electric current. If the electrolyte is weak electrolyte, it will conduct less electric current. And it also depends upon size of ions. Size of ions. If the size of ion increases, its mobility decreases. So conduction also decreases. And also it depends upon solvation. If ions are more solvated, so this solvation also affect its mobility. Okay, about them we will discuss in later, or in further concepts we will discuss about them. Okay. Next, the nature of solvent and its viscosity. The conductance of electrolytic solution also depends upon nature of solvent and its viscosity. If solvent is polar solvent, what happens? It allows the ions to pass very much early. If the solvent is non-polar solvent, so there exists some hindrance to the movement of ions. If viscosity, if the solvent is more viscous, then what happens? Viscous means what? The ions cannot move fastly. The conductance decreases. If viscosity of the solvent is very less, then ions can move freely. The conductance increases. Next, concentration of electrolyte taken. Here, the conductance of electrolytic solution also depends upon concentration of electrolyte. If I take less amount of electrolyte, the less amount of electrolyte means lesser number of ions are present in the solution, means conductance less. Conductance is less. If I take more amount of electrolyte, what happens? More number of ions are produced in the solution, so conductance also increases. And again, the most important factor is temperature. Here also, the most important factor is temperature. For them, here the opposite criteria happens here. The opposite thing happens here. Temperature, ionic conductance increases with increase in temperature. Please remember, ionic conductance increases with increase in temperature. Why it should increase? So here, in case of metallic conductors, the conductance of metallic conductors decreases with increase in temperature. But in case of ionic conductor, what happens? The conductance of ionic conductors increases with increase in temperature. Two types we can explain this. There are two reasons. The first one, as temperature increases, what should increase? The kinetic energy of ions increases. As kinetic energy of ion increases, the mobility of ion also increases. If the ions start moving very fastly, the conduction also increases. First thing. Second thing, in a beaker, if I add acetic acid, the degree of dissociation of acetic acid is very less. All of you know about that. Degree of dissociation means what? Dissociation of acetic acid into ions. If acetic acid is dissolved in the solution, CH3COOH, if it is dissolved in the solution, it is dissociated as CH3COO minus plus H plus. If I take 100 molecules of acetic acid, only 10 molecules are dissociated. Means what? Only the 10 molecules of H plus ions are there, 10 CH3COO minus ions are there at low temperature. If temperature increases, what happens? If temperature increases, degree of dissociation also increases. As temperature increases, degree of dissociation is also increases. As a result, more number of ions are dissociated. Now, at high temperature, 80 molecules of acetic acid are converted into acetate ion and H plus ion. As number of ions are increased, its conductivity also increases. Okay. So this is about the conductors and type of conductors, metallic conductors and electrolytic or ionic conductors. Okay. So dear students, I hope all of you understood about this. Thank you so much, and please like, comment and share among your friends. If not yet you are subscribed to my YouTube channel, please go and subscribe. Thank you so much for watching.